So let's try this problem now. So this tells us to find the magnitude of the resultant force. And I got 40 pounds on the one vector, 60 pounds on the other vector, and 40 degrees between them. So all we're going to do is the same thing here. So I'm thinking the parallelogram idea here. And these, I mean, for me, usually that's the easiest. I don't have to move anything a lot of times, and it just usually pans out to be very nice here. So let's find out what this is. So I'm going to get, this line going straight across there. And I can actually find out what that is. Now I know this also up here would be 60. I know this also over here would be 40. And the thing is, all I need is one of these, and I can think of the idea of the triangles. But this isn't necessarily going to split it into 20 degrees and 20 degrees. It's not going to be an angle bisector for us. So what we're going to end up having to do here is we're going to have to think of the parallelogram completely. So we're going to use a similar idea that we use for a triangle. So we know the sum of the angles of a triangle is 180. So if I have two triangles, so that would be this one, this side, this angle, that angle, that angle, that angle, that angle. So I know each triangle is 180 degrees. So then for a parallelogram, it would be 360 degrees. So from this, I can actually find out what those angles are. So this one's 40 over here. We were given that. So the one opposite it over there is also going to be 40. So between those two, we have 80 degrees. Okay, and we also know these angles. We don't know what the values of them are, but we know that they're going to be the same angle. So I can say plus 2, call it x if I want to, equals, and we know altogether it's 360 degrees. So then I move the 80 over, so subtract 80. So then I get 2x equals 280. And then I divide by 2. So x equals 140 degrees. So now I know this here is 140 degrees. Now I can actually use one of my cool little tricks to figure out the rest of this. So now take a look at this. Now all I'm going to do is look at this triangle now. And if you think about what I have here, I have this side, that angle, and that side. So what I can use here is the law of cosines. And the law of cosines would tell me if I want to find this side, let me call it A, then I would get A squared equals 60 squared plus 40 squared minus 2 times 60 times 40 times cosine of 140 degrees. And that's what I'm going to end up with. So I can work this out, and I'm just going to fly through it really quick here. And then don't forget, when we get down to this step, don't forget we have to square root both sides. Now again, I only really have to worry about the positive one because I'm talking about the side of a triangle, and here I'm talking about a resultant force. So that's going to result in, which if we're doing 3 sig figs like I kind of talked about previously, my A is going to equal 94.2 pounds. Because remember, we were talking about the magnitude of the resultant force. And the magnitude is going to be over here, which is pounds. Okay, so there's our answer.